first class of Industrial Hydraulics Module 2. So in this module, completely dealing with the pump, different types of pump used in the hydraulic circuits. So we are starting with the introduction about a pump. See, pump is the heart of a hydraulic system, which generate the force necessary to move the load. Pump actually convert mechanical energy into hydraulic energy. That hydraulic energy will be utilized by the actuator. Actuator convert hydraulic energy into again mechanical energy, resulting a force or a rotation or torque. See, the pump is always connected to a prime mover, that is an electrical motor. So classification of pump. This is general classification. So first classification based on displacement. Based on the displacement, pump are classified into hydrodynamic pump and hydrostatic pump. Hydrodynamic pump is known as non-positive displacement pump. Hydrostatic pump is known as positive displacement pump. So based on the displacement, pump are classified into positive displacement pump and non-positive displacement pump. Actually, positive displacement pump are commonly used in the hydraulic system. Second classification based on delivery. Based on delivery, pump are classified into constant delivery pump and variable delivery pump. Constant delivery pump means the output delivery of a pump cannot be varied by the operator. Variable delivery pump means the output delivery of the pump can be varied by the operator. Classification based on motion. Based on the motion of pumping element, pump are classified into rotary pump and reciprocating pump. So these are the classification of pump. First classification based on displacement, positive displacement pump and non-positive displacement pump. Classification based on delivery, constant delivery pump or variable delivery pump. Classification based on motion, rotary pump or reciprocating pump. So this is the chart which explain classification of pump. So pump are classified into dynamic pressure pump, non-positive displacement pump and positive displacement pump, hydrostatic pump. So in dynamic pressure pump, that means non-positive displacement pump, hydrodynamic pump, example are centrifugal pump, propeller pump, turbine pump. See, positive displacement pump, it is again classified into three types, that is reciprocating pump, rotary pump, linear pump. Piston pump and diaphragm pump are example for reciprocating pump. Gear pump, lobe pump, screw pump, vane pump, rotary plunger pump are example for rotary type positive displacement pump. Rope pump and chain pump are example for linear type positive displacement pump. So first of all, we are going to discuss about what you mean by positive displacement pump. See, positive displacement pump, it is also known as hydrostatic pump. So what is the importance of positive displacement pump in hydraulic system? In hydraulic system, commonly using pump is positive displacement pump. Positive displacement pump are high head, low discharge pump. See, generally pump is classified into positive displacement pump and non-positive displacement pump. Positive displacement pump are high head, low discharge pump and non-positive displacement pump are low head, high discharge pump. In household application, we are commonly using non-positive displacement pump or hydrodynamic pump. Why? See, in household application, the objective is to fill the tank in a short period. So there should require high discharge. The head have no importance because we are not producing any work output by using that head. So in household application, always using low head, high discharge pump, for example, centrifugal pump. But in hydraulic circuit, the objective of hydraulic circuit to produce a work output using the pressure energy of the fluids. So in positive displacement pump are commonly high head, low discharge pump. So there is no importance of discharge. Importance of head will be important. That is, pressure head will be important. That pressure energy will be utilized to produce a work output. So positive displacement pump are high head and low discharge pump. See, another important characteristic of a positive displacement pump is, in the case of positive displacement pump, there will be a discharge, whatever be the rotation speed of the pumping element, there will be always a discharge. That's an important point. In positive displacement pump, there will be always a discharge. There will be always a discharge will be there, whatever be the rotation of pumping element. So in positive displacement pump, for example of positive displacement pump is the reciprocating pump, is a positive displacement pump. Piston gear pump is a positive displacement pump. Vane pump is a positive displacement pump. Piston pump is a positive displacement pump. So in all positive displacement pump, there will be a discharge. Whatever be the discharge pressure or whatever be the speed of rotation of pumping element. See, what are the types of positive displacement pump? Positive displacement pump are classified into rotary type, first one, reciprocating type, and third one, linear type. So this classification is based upon the motion of pumping element. See, in rotary type positive displacement pump, the pumping element is rotated. For example, gear pump, vane pump. In gear pump, vane pump, the pumping element is rotated when the pump is working. In reciprocating type pump, the pumping element is reciprocating while the pump is working. For example, plunger pump, piston pump, diaphragm pump, circumferential piston pump, etc. In linear type post displacement pump, the pumping element have a linear motion. For example, rope pump, chain pump, etc. So these are three classification of post displacement pump. That's very important. So the post displacement pump are classified into rotary type, reciprocating type, and linear type pump. Okay. So non-positive displacement pump or hydrodynamic pump, high discharge, low head pump. See, these type of pump are commonly not using in hydraulic system applications because these type of pump will produce high discharge, low head. So as it have low head or low pressure, there is no work output will be producing. So these type of pumps are commonly using in the household applications only. So what is the importance of non-positive displacement pump or hydrodynamic pump? See, centrifugal pump is an example for a non-positive displacement pump. One of the biggest example for non-positive displacement pump. So in the case of centrifugal pump, how the discharge will be taking place? See, in the case of centrifugal pump, see this is the figure of a centrifugal pump. So here impeller will be rotating. This portion is known as I. So when the impeller is rotating, here in this portion a vacuum pressure will be creating. Due to this vacuum pressure, the hydraulic oil or fluid that will be above atmospheric pressure. That atmospheric pressure is acting over the fluid surface. So due to this pressure gradient, atmospheric pressure that will pull the fluid into the eye. So when the rotation speed of the impeller is low, low vacuum pressure is created. When the rotational speed of the impeller is high, high vacuum pressure is created. So the pumping will be depending upon the rotation of element, rotational speed of the element in the case of centrifugal pump. But in reciprocating pump, the whatever be the rotation speed of the pumping element, there will be always a discharge. But here the rotation speed is proportional to the discharge of the pump. That's the main characteristic of hydrodynamic pump. Centrifugal pump is one of the best example for hydrodynamic pump. So what is the advantage of hydrodynamic pump? Low initial cost and minimum maintenance, simplicity of operation and high reliability, capable of handling any type of fluid such as sludge and slurries. So these are the advantages of post displacement pump actually. Not a hydrodynamic pump, post displacement pump. Low initial cost and minimum maintenance, simplicity of operation and high reliability, capable of handling any type of fluid, sludge and slurries. Disadvantage, non-post displacement pump are not self-priming. So this is a this is the advantage of non-post displacement pump actually. Okay. So non-post hydrodynamic pump, non-post displacement pump are not self-priming and hence they must be positioned below the fluid level. Discharge is a function of output resistance, low volumetric efficiency. So this is the advantage and disadvantage of hydrodynamic pump or non-post displacement pump. Okay. So next one is pump theory. In In the case of positive displacement pump, what is a pump theory? So we are going to discuss about post displacement pump, not hydrodynamic pump. Okay. So post displacement pump are mechanical device which convert mechanical energy into hydraulic energy and driven by a prime mover that is known as electrical motor. That's the first definition of a post displacement pump. It is a mechanical device which convert mechanical energy into hydraulic energy, and pump is connected to a prime mover that is electrical motor. See, every positive displacement pump perform two functions or working in two stages. First stage is it will create a partial vacuum near the inlet port. So due to this vacuum, the atmospheric pressure that pull the hydraulic oil into the pump chamber or fluid into the pump chamber. That's the first stage. In second stage, the pumping element exert a force over the fluid and the fluid get pressurized, and that pressurized fluid flow to the discharge line to the hydraulic system. So these are the two stages in any post displacement pump. For example, we have a reciprocating pump. Reciprocating pump is a post displacement pump. There are several classifications of post displacement pump. These classifications are we are discussing in this module. We have gear pump, vane pump, lobe pump, piston pump, screw pump, etc. Okay, so first of all, I am going to explain what is a pump theory, basic principle of working of a post displacement pump. So post displacement pump working in two stages. First stage, a partial vacuum will be created near the inlet port. Due to the partial vacuum near the inlet port, the atmospheric pressure pull the hydraulic oil or fluid to the pump chamber. Next stage, the pumping element exert a pressure over the hydraulic oil. Due to that pressure, the hydraulic oil get pressurized, and that high pressure hydraulic oil flow to the discharge line through discharge port. So this is happening in any post displacement pump. So here you can see that this is a hydraulic reservoir. We have a hydraulic filter. This is the inlet pipeline and this is the outlet pipeline, inlet port, inlet valve or outlet valve. So this is a pump chamber. So what is happening when the piston is moving in backward direction? When the piston is moving in backward direction or outward direction, so expansion will be take place inside the pump chamber. There will be expansion will be taking place. Due to this expansion, a partial vacuum is created near the inlet port. Here, a partial vacuum will be creating here. Due to this partial vacuum, see here, what is the condition? Atmospheric pressure exert a pressure over the hydraulic oil. Here is partial vacuum. So there is a pressure gradient is here. So due to this pressure gradient, when the atmospheric pressure exert pressure over the hydraulic oil slowly flow through the pipeline to the chamber. So hydraulic oil is filled inside the pump chamber. Then the second stage. In second stage, the piston move forward direction. When the piston move forward direction, the piston exert a force over the hydraulic oil. Due to this force, the hydraulic oil get pressurized, and that pressurized hydraulic oil flow through to the outlet pipeline through the outlet valve. So this is the pump theory. This is the working principle of any positive displacement pump. So every positive displacement pump, there is a partial vacuum is created at the inlet port in initial condition due to expansion of the chamber. Second stage, the pumping element exert a force over the hydraulic oil. The hydraulic oil pressurized hydraulic oil flow to the outlet pipeline. So this is the basic principle of a positive displacement pump. Okay. So first of all, we are going to discuss about gear pump. So gear pump is a mechanical device. It is made up of combination of two gears. It consists two intermeshing gear. It is a rotary type post displacement pump. The pumping element is rotating during the pumping process. And this is the one of the commonly using post displacement pump in hydraulic system, and it is less expensive and it will produce pressure up to 140 bar. Less pressure is produced actually by gear pump. So gear pump, it's a post displacement pump. It's a rotary post displacement pump. It's a mechanical device that will convert mechanical energy into hydraulic energy. It consists two intermeshing gears and it will produce a pressure up to 140 bar, and it is way less expensive positive displacement pump. See, there are three classification of gear pump. That's very important. Classification of gear pump. Gear pump are classified into external gear pump, internal gear pump, and gear rotor pump. External gear pump, internal gear pump, and gear rotor pump. So we can discuss one by one. What is the construction feature and working of external gear pump? What is the construction feature and working of internal gear pump? And finally, gear rotor pump. So first of all, external gear pump. So we can discuss by showing the figure. What is external gear pump? So this is the figure of external gear pump. All of you see the figure of external gear pump. Okay. See, external gear pump consists two intermeshing spur or helical gear. That's the first point. External gear pump consists two intermeshing spur or helical gear mounted inside a casing. So this is the casing, and this is the intermeshing spur or helical gear that is mounted inside a casing. One gear is driver gear that is connected to the prime mover, that is electric motor. See here, this is the driver gear that is connected to the prime mover, that is electric motor, and another gear is ideal gear. The driver gear is rotating in clockwise direction. You can see that the driver gear is rotating in clockwise direction. The ideal gear or driven gear is rotating in anti-clockwise direction. So during the working of the external gear pump, see a nearby inlet area, see this is the inlet area, a partial vacuum will be created due to unmeshing of the gears. So in this area, the unmeshing of the gear will be taking place. Due to unmeshing of the gear, the chamber size will be increasing. Due to the chamber size will be increasing, a partial vacuum will be created nearby this inlet area. Due to this partial vacuum, the hydraulic oil fill into the chamber. Hydraulic oil that will be trapped between gear teeth, two adjacent gear teeth, and the casing in both gears. So hydraulic oil that will be coming to this area, this inlet port area, that will be trapped between two gear teeth and casing and carried to the outlet or discharge port, both two side of the pump. So here also the hydraulic oil will be carried to here. This side also hydraulic oil will be carried to here. So when the hydraulic oil is carried to the discharge port, the teeth of the gear that exert a pressure over the hydraulic oil, and the pressure of the hydraulic oil will be getting increased. See, the teeth will exert when the gear teeth are gears are rotating, and the hydraulic oil that is trapped between the gear teeth and the casing, when rotating, when the gear teeth is rotating, the teeth will exert a pressure over the hydraulic oil, and the hydraulic oil will be get pressurized, and that high pressure hydraulic oil that will flow to the discharge line through outlet port. So this is the working of an external gear pump. So what is the advantage of an external gear pump? Simplicity and compactness, low cost, a few moving parts, less sensitive to contamination, high operating speed, quiet in operation, and gear pump are reversible rotated. So this is the construction feature and working of a external gear pump. Okay. Next one is internal gear pump. So this is the figure of an internal gear pump. See, internal gear pump First of all, I am going to discuss about the construction feature of an internal gear pump. Then I will discuss the working of an internal gear pump. Okay. Internal gear pump consists one inner gear which is inside the second outer gear. That's the first one. Internal gear pump consists one inner gear. This is the inner gear which is inside the second outer gear. So this is the outer gear. You can see that this is the outer gear and this is the inner gear. So in the inner gear pump consists one inner gear which is inside the second outer gear. Inner gear that is connected to the electrical motor through a shaft. Inner gear that is also known as ring. Inner gear that is connected to the electrical motor through a shaft. Inner gear have teeth protrude in outward direction. You can see that inner gears have the teeth is protruding in outward direction. You can see this. The teeth will be protruding in outward direction. But outer gear that is also known as ring gear, and the outer gear have teeth protruding in towards the center of the pump or inward direction. So both gears are rotating in same direction. When the internal gear is rotating, the external gear also rotating in the same direction. See, between these two gears, there is a spacer. It is called crescent seal. That is a stationary piece mounted between the two gears in the housing. So this is a spacer. Between these two gears, there is a stationary piece that is known as spacer that is mounted in the casing between the two internal gear and external gear. So these are the construction feature of internal gear pump. Once more I will explain. Internal gear pump consists one inner gear that is mounted inside the outer gear. Inner gear that have teeth protruding in outward direction. And inner gear is connected to electrical motor that is prime mover through a shaft. Outer gear that is known as ring gear. Outer gear have teeth protruding in inward direction or toward the center of the pump. Between the inner gear and outer gear, there is a stationary piece that is known as crescent seal that is mounted inside the casing. So these are the constructional feature of a internal gear pump. So working, what will be happening? See, working, you can see that when the inner gear is rotating, it will be continuously meshing and unmeshing with the outer gear. So here, nearby inlet port, the unmeshing will be taking place. So when the gear teeth will be get unmeshed, what is happening? The chamber size will be increasing. When the chamber size will be increasing, a partial vacuum will be created. A partial vacuum will be created nearby inlet area. Due to the partial vacuum, hydraulic oil will be pushed in the pump chamber and that will be trapped between two gear teeth, both inner gear and outer gear. See once more, during the working of a internal gear pump, see the internal in this nearby inlet area, the gear teeth will be disengaged. That means unmesh. When the gear teeth will be unmesh, the size of the chamber will be increasing. Due to size of the chamber will be increasing, a partial vacuum will be created here. Due to this partial vacuum, the hydraulic oil enter into this inlet area and it is trapped between gear teeth, both internal gear and external gear. Then that trapped hydraulic oil carried to the outlet port or discharge port, both side of the crescent seal. See, you can see that here is a stationary piece will be here that is known as crescent seal. So the hydraulic oil will be trapped between the gear teeth. So hydraulic oil will be trapped between these two gear teeth. Also the hydraulic oil will be trapped between the bottom gear teeth of the other side of the crescent seal. So when it will be carried to the outlet port, what will be happen? Nearby outlet port, the teeth will again get engaged. When the teeth will be get engaged, it will pressurize the hydraulic oil, and that pressurized hydraulic oil pushed into the outlet port to the discharge line. So this is the working principle of an internal gear pump. Once more, see in inlet area, nearby inlet area, disengaging, the gear teeth will be get disengaged. Unmeshing take place. Due to unmeshing, there is a partial vacuum will be created nearby the inlet area. Due to this partial vacuum, hydraulic oil will be flow to the inlet area trapped between the gear teeth, both internal gear and external gear. So and it is carried to the discharge port through discharge port. So the hydraulic coil that is carried to the uh, space chamber between the gear teeth, both internal gear and external gear, both sides of the space or crescent C. So when the hydraulic coil will be reaching the discharge line, discharge port, nearby discharge port, what is the condition is, again engagement of teeth will be taking place. Due to this engagement, the hydraulic coil will be get pressurized. That high pressure hydraulic coil that will be put into the discharge line through discharge port. So this is the working of an internal gear pump. So what is the advantage of internal gear pump? First one, only two moving parts, non-pulsing discharge, excellent for high viscous fluids, operate well in either direction, easy to maintain, noise will be very less compared to external gear pump. So these are the advantage of internal gear pump. Then what are the disadvantage? Usually require moderate speed, medium pressure limitation, pressure geared up to 350 bar only, overhang load on the shaft beer. So load will be, there will be hydraulic coil will be only carried in the two sides. So there will be either in this side there is no hydraulic coil. Only one side the hydraulic coil will be carrying. So on the shaft there will be uniform distribution of the load will be there. Shaft will be break. Application used for all varieties of fuel oil and lube oil, used for resin and polymers, alcohol and solvent, for food products such as corn syrup, chocolate and peanut butter. So these are the application where we are using internal gear pump. And the third classification is gear rotor pump. See, gear rotor pump have one high application because that is used as a fuel injection pump in automobile pump. That's an important point related to gear rotor pump, which is used as a fuel injection pump which is used as fuel injection pump in automobile. Okay, see, gear rotor pump is basically a post displacement pump, the name derived from generator rotor. Okay, so we can go to the figure. So this is the figure of the gear rotor pump. See, gear rotor pump consists an internal gear and external gear. So this is the internal gear and this is the external gear. This is internal gear and this is an external gear. This is the pump casing. So gear rotor pump consists an internal gear and external gear. So internal gear that is known as, or inner gear that is known as gear rotor gear. So inner gear have n number of teeth. See, this is the inner gear. Inner gear have n number of teeth. Outer gear have n plus 1 number of teeth. That's an important point in the case of gear rotor pump. Inner gear have n number of teeth. Inner gear have n number of teeth. Outer gear have n plus 1 number of teeth. Axis of rotation of both gear are different. So when the gear is rotating, the size of chamber will be varying. So nearby inlet area, the chamber size will be increasing. Due to the chamber size will be increasing, a partial vacuum is created here. The hydraulic coil will be trapped inside the gear teeth, between gear teeth, that is carried to the outlet port. Nearby outlet port, the engagement of gear teeth will be taking place. Due to the engagement, the oil will be get pressurized. That pressurized oil will be put into the discharge line or outlet line through outlet port. So this is the working of a gear rotor pump. Once more I will explain what is the working of gear rotor pump. So in the case of gear rotor pump, which consists an inner gear and an outer gear. Inner gear is driving gear and outer gear is actually ideal gear that will be rotating when the inner gear will be rotating. So inner gear, that is known as gear rotor gear. Inner gear have n numbers of teeth. Then outer gear have n plus 1 number of teeth. and the inner gear and the outer gear are rotating in two axes. So as the inner gear and outer gear are rotating two axes, the chamber size will be varying when the gear is rotating. So nearby inlet port, the chamber size will be increasing. As the chamber size will be increasing, a vacuum pressure will be, a low pressure will be creating near the inlet port. Hydraulic oil will be flow enter into the pump chamber and trapped between the gear teeth, that is carried to the outlet port. Nearby outlet port, the engagement of teeth will be starting. Due to the engagement of teeth will be starting, the hydraulic oil will be getting pressurized. That pressurized hydraulic oil will be pushed into the discharge line through outlet port. So this is the working of a gear rotor pump. So what is the advantage of gear rotor pump? These type of pump have 25 efficiency higher than gear pump. That is the first advantage. Less sound because of less number of engaging teeth. These are used in automobile fuel injection pump. That's a very important point. Gear rotor pump is using automobile uh, fuel injection pump. Okay. So this is about the gear rotor pump. So this section we can wind up. In this section, I have discussed about pump definition, classification of pump, pump theory, gear pump, three classification of gear pump, external gear pump, internal gear pump, and gear rotor pump. Okay, thank you.